Hello everyone, welcome to SCI-EASE. In this video, I'm going to start the refraction of light by the spherical lenses. You must have seen palmist seeing the lines on the palm with the help of magnifying glass or lens. You must have seen the watchmaker to see the small parts of the watch by lens. So lens that is used in our day-to-day life, it has a great role in our day-to-day life. Lenses are used in spectacles, cameras, microscope, telescope, and many other optical instruments. So, I want to tell you this thing that in case of the mirror, the reflection phenomena that takes place. Here the lenses, by lenses, refraction of the light rays that takes place. So first thing is, what is a lens? A lens is a piece of transparent glass bound by two spherical surfaces. So it is, you must have seen the lenses, you must have seen the spectacles. So you have seen the lenses, you must have seen the magnifying glass also. Okay? So a lens is a piece of transparent glass. एक transparent glass है, which is bounded by two spherical surfaces. Like mirrors, lenses are also of two types. First one is the convex lens. First is the convex lens and second is the concave lens. So what is the convex lens? First I will draw that. Convex lens that is thicker at the middle. Okay? It's thicker at the middle and it tapers towards the ends. So this is the convex lens and it has two surfaces. You can mark it like this is A and this is B convex surface. Okay? And this is the convex lens. And what is the concave lens? It is thin in the middle and thicker towards the ends. Okay? Suppose this is C surface, this is D surface, D concave surface, and this is C surface. Okay? So, these are the diagrams. You must know. Then and then only you can draw the images formed by the convex lens and the concave lens. So, convex lens is thicker at the middle and it tapers towards the end, and concave lens that is thinner in the middle and it is thicker at the two ends. So, this thing that is clear to all of you. Now, next thing is that you should know certain terms before knowing the rules also for the images formed by the concave or the convex lens. So what are those terms? One is optical center. What is optical center? I will draw with a red pen. The center of the lens, which is marked by C, that is the optical center of the convex lens, and here it is the optical center of the concave lens, also marked by C. So one term that is clear, optical center is in the center. And I must tell you this thing, that when the ray of the light passes through the optical center, it will go in a straight line. There will be no deviation in this case. Okay, there will be no deviation. It will go straight as it is normal to both the faces of the lens. So the ray, suppose I will draw another diagram to show you the various terms. Okay. This is the convex lens. This is center C. So when the ray of light, it passes through the optical center, there is no deviation. It will go straight. Okay? So, one term is clear, no deviation at this point, and it is in the center. This is for the convex lens. Now, another is principal axis. The line which passes through the optical center and it goes straight, that is the principal axis. Okay, so this is the principal axis. Now next is about the principal focus and the focal length. Suppose this line, it goes straight. When the rays of light parallel to the principal axis, they strike the lens, they will converge at one point. They will converge at one point, and this point is known as the principal focus. This is the principal focus. When the rays parallel to the principal axis, they start from left hand side, they will meet at one point after refraction, and that point on the right hand side, this is the principal focus. One very important thing, that refraction that can take place from this side also. The lines, when they are parallel to the principal axis, they will strike the lens, B phase of the lens. Then they will meet at the point known as, again, principal focus, which is denoted by F dash. Okay, so there are two principal foci for the convex as well as for the concave lens. And you know that this lens, convex lens, that is the converging lens. The rays, they will converge at this point. Okay, so this is and you should know that the distance between CF and the CF dash, here it is F dash, that should be equal. Okay, that should be equal. This thing, that should be clear to all of you, that F dash and the distance of the F and F dash, it should be same from the optical center. Clear? Now next term is the focal length. But one activity I want to tell you about this thing, you place one paper on the ground, and then allow and place the convex lens in such a way so that the bright image of the sun that is formed on the paper, you keep the lens as it is for some time. What you will see, that the point where there is principal focus, means where the rays they meet and form the image, that will be burnt. That will burn and it will form a hole in the paper. So that's why don't see the sun by keeping convex lens before you. Okay, convex lens, what it will do, that the rays they will converge and they will damage your eyes. Okay, so this thing that should be clear to all of you. Next term, that is the focal length. So what is focal length? It is the distance between the optical center and the focus or the principal focus. This is the focal length. So how many terms we have done? First one is the optical center. Where it is? It is the C point, the center of the lens. That is the optical center of both the lenses. Second term we have done, that is the principal axis. Principal axis. What is principal axis? The line passing through the center of the lens, or you can say optical center, and it's perpendicular to both the faces, that is the principal axis. Third is the principal focus. Principal focus. So the rays parallel to the principal axis, when after refraction they will meet at one point which is known as the principal focus, and if the rays they start from right hand side and they will fall on the lens, then the principal focus will be on the left hand side. Okay, and the fourth term which we have done, that is the focal length. Focal length. So what is focal length? The distance between the optical center and the focus, that is the focal length of the lens. So I have told you about the convex lens. You must remember this thing, that convex lens, that is the converging lens. This means that the rays they will meet at one point. Now come to this concave lens. Concave lens, I have told you that it is thinner in the middle and it is thicker towards both the ends. Now here I will again draw, and when the rays this is the convex lens, concave lens, sorry, and this is the center C. This is center C. Now the rays, when, and this is the principal axis, first I will draw, it will go straight. Okay. Now the rays parallel to the principal axis, they will fall on the lens. Okay. They will fall on the lens and they will diverge. This is the converging lens and this is the diverging lens. So same here, it will diverge. You can draw more rays. So they are diverging towards arrows. They will show that the rays, they are going in this direction. But when we will produce this with a dotted line, what you will see, that they will meet at one point on the, they will meet at one point on the principal axis, which is the focus. Which is the focus. This is the F. This is the focus. Draw it neatly. Okay. So, when the rays parallel to the principal axis, they will fall on the concave lens. The rays, they will diverge, and when we will produce it with the dotted line, we will see that they appear to meet, you can say, at F. So this is the, again, now here the focus F, it is the virtual. It is the virtual. Here it is the real focus. This is the virtual focus. Again, there will be F if the rays, they start from this side. If the rays, they will start from this side, they will diverge, okay, and they appear to come from F dash. And the distance between CF and CF dash, that should be equal. Again, there are two principal foci. Here also there are two principal foci. All the four terms, optical center in the center, okay. Then is the principal axis, line passing through the C, and then is the principal focus. This is the diverging lens. This is the diverging lens. They will diverge, rays will diverge. And when we will produce it, they appear to meet at the point F. And here also there are two principal foci. And what is the last term, focal length? It is the distance between C and F. It is the distance between C and F. This is the focal length of the lens. So I think these things, they are clear to you that what are convex and concave lenses. Now I will tell you about the rules by which we can draw the images formed by the convex and the concave lenses. Now the first rule, that is rule 1. What is that? This is I am telling you the rules for obtaining images by the convex lens. So I will draw the convex lens. This is the convex lens. Okay. This is optical center. And this is the principal axis. The first rule is when the ray parallel to the principal axis, and this is C, mark C, F dash, approximately same distance, F. Okay, this is F. Now the ray parallel to the principal axis, when it will strike the lens, after refraction, it will pass through the focus. Okay, we will consider the two rays. Okay, where the image that will be formed when these two rays, out of these three rules which I am going to tell you, the two rays we will take, and where these two rays meet, the image that will be formed. So by that you can tell the position and the nature of the image formed. So rule 1 is when the ray parallel to the principal axis falls on the lens, after refraction, it will pass through the focus. You must write this thing, but I have told you by drawing the diagram. What is rule 2? What is rule 2? I have told you that when the ray, it passes through the optical center, it will go straight. So this is the optical center. This is F dash. This is F. This is C. So when the ray, it passes through the optical center, it will not be deviated. It will go straight. So this is the second rule. Now what about the third rule? Rule third. What is rule third? Draw again the convex lens, principal axis. Okay, this is C, F dash and F. The third is when the ray, it passes from the principal focus. Okay, when it passes through the principal focus, it will become parallel to the principal axis. Same as the rules are same. We have done in the case of the convex and concave mirrors. Here also this is the same rule, that when the ray passes through the principal focus, it should be straight. Line should be, you will draw with a scale. Okay. When it passes through F dash, this is F dash, principal focus, it will become parallel to the principal axis. So these are the three rules by which you can draw the images formed by the convex lens for the various position of the object. So in the next video, I will take up the images formed by the convex lens. Till then, thank you very much.